Hi children, in this video class we are going to learn one of the important 8 marks question in organic chemistry, that is methods of preparation of acetylene and its chemical properties. Acetylene is also known as ethane. Its chemical formula is C2H2. So we can draw its structure as CH triple bond CH. ఎస్టిలిన్ లో మనకి 2 కార్బన్ ఐటమ్స్ 2 హైడ్రోజన్ ఐటమ్స్ అనేవి ట్రిపుల్ బాండ్ ద్వారా అటాచ్ అయి ఉంటాయి. సో ఈ ఎస్టిలిన్ని మనం ఈథైన్ అని కూడా అనడం జరుగుతుంది. ఫస్ట్ ప్రిపరేషన్ మెథడ్ ఈజ్ ఫ్రమ్ కాల్షియం కార్బైడ్. సో ఎస్టిలిన్ ఈజ్ ప్రిపేర్డ్ ఫ్రమ్ కాల్షియం కార్బైడ్ by treating with water. Acetylene is prepared by treating with calcium carbide with water. The chemical equation is CaC2. Calcium carbide formula is CaC2. We are treating with water. So 2H2O gives rise to, it forms CaOH, calcium hydroxide, CaOH twice, and C2H2. This is acetylene. So we can explain this chemical reaction as CaC2. So in acetylene we have 2 carbon atoms and 2 hydrogen atoms. So 2 carbon atoms from calcium carbide, and here we have 2 2s are 4 hydrogens. So in this 2 hydrogen atoms from water forms C2H2, and remaining elements are calcium and 2 2s are 4, in which 2 hydrogen atoms are formed as H2. So still how many left? There are 2 more hydrogen atoms. So hydrogen, and here we have another 2 oxygen atoms. We can write as CaOH twice. Calcium carbide is treated with water. Otherwise మనం దీన్ని ఏ విధంగా అనొచ్చంటే hydrolysis of calcium carbide forms calcium hydroxide and acetylene. Calcium carbide reacts with water to form acetylene and also calcium hydroxide. This is the first preparation. Second preparation is from 1,2 dibromoethane. 1,2 dibromoethane is treated with alcoholic KOH to form bromoethane. Further, it is treated with sodamide to give acetylene. The chemical reaction is first we have to write 1,2 dibromoethane. Bromine, remaining all are hydrogen atoms. This is 1,2 first carbon, second carbon, 1,2 2 bromine atoms, dibromoethane. Dibromoethane is treated with KOH, alcoholic KOH, potassium hydroxide. So alcoholic, so we have to take the medium in alcohol. So it loses KBr, potassium bromide, and also 1 water molecule. So then it becomes C double bond C, hydrogen, bromine, hydrogen, and hydrogen. The name of this compound is bromoethane. Further it is treated with sodamide. Sodamide formula is NaNH2. So it loses NaBr, sodium bromide. Then it becomes C triple bond C. Here 1 hydrogen, here another hydrogen. C bond H, C bond H. This is nothing but C2H2. The second preparation is from 1,2 dibromoethane. This is 1,2 dibromoethane. He is treated with alcoholic KOH, forms bromoethane. The name of this compound is bromoethane. Further, this bromoethane or bromoethane is treated with sodamide. This one is sodamide. Is treated with this compound, bromoethane is treated with sodamide, forms acetylene. The formed product is acetylene. This is the second preparation method. Third preparation method is from haloform. We already know the halogens, fluorine, chlorine, bromine, iodine. So out of these four halogens, we can take any one. So I am taking iodoform. Iodoform. The iodoform chemical formula is CHI3. CHI3. Acetylene is prepared by heating of iodoform. We are heating the iodoform CHI3 plus we are heating the iodoform in the presence of silver powder. The chemical equation is CHI3 plus 6Az plus CHI3. So it can form acetylene CH triple bond CH. So we lost here two carbon atoms, first carbon, second carbon, and two hydrogen atoms, first hydrogen, second hydrogen. Still remaining elements are three iodines here three more iodines, and six silver atoms. So overall you can write it as 6 AZI. From haloform, iodoform is treated with silver powder, it can form acetylene. This is the third preparation method. Now, chemical properties of acetylene. Acetylene contains triple bond. Always triple bonded and double bonded carbon atoms undergoes addition reactions. So, acetylene also undergoes only addition reactions. First chemical property is addition of dihydrogen. Addition of dihydrogen. Second one is addition of halogens. Halogens. Third one is addition of hydrogen halides. Hydrogen halides. And fourth one is addition of water. Addition of water. The fifth one is addition of hydrogen cyanides. Addition of hydrogen cyanides. And the sixth one is cyclic polymerization. Cyclic polymerization. Right? Dihydrogen, nothing but we have to add H2 halogens. So fluorine, chlorine, bromine, iodine. So out of these four halogens, we are preferring Br2. And hydrogen halides. Hydrogen halides, we are adding HBr. Addition of water, H2O. Addition of hydrogen cyanides, HCN. And cyclic polymerization. Acetylene undergoes cyclic polymerization. Right? So now we are going to discuss one by one chemical properties of the acetylene with chemical equations. First one, addition of dihydrogen. Acetylene on addition with dihydrogen in the presence of nickel, platinum or palladium catalyst, it forms ethylene. Further, it forms ethane. The chemical reaction is as follows: CH triple bond CH. We are adding H2 in the presence of nickel, palladium or platinum catalyst at 140 degrees Celsius. So we are adding H2. So if you combine dihydrogen to this acetylene, the triple bond becomes double bond. So it becomes HC double bond CH, and the two hydrogens are added to each carbon atoms. First hydrogen, second hydrogen. This is ethene. Further, it is treated with nickel or palladium or platinum catalyst. By adding of dihydrogen, the double bond becomes again single bond. The chemical reaction is C single bond C. First hydrogen, second one, third one, fourth one, fifth one, sixth one. So in this equation, so first of all, the triple bond by the addition of H2, this triple bond becomes double bond. Again further adding of H2, this double bond becomes single bond. This is acetylene or ethane. This is ethene in alkene family. This one is ethane. That's why acetylene is always undergoes addition reactions. Second one, addition of halogens. Acetylene on addition with any halogen like bromine in the presence of carbon tetrachloride, first it forms 1,2 dibromoethane. Further by adding another 2 bromine atoms, it forms 1,1 2,2 tetrabromoethane. The chemical equation is, so acetylene is treated with halogens. That halogen is Br2. So addition reactions. That means here triple bond becomes double bond. 2 bromine atoms bonded with each carbon atom. C double bond C, hydrogen, hydrogen. 2 bromine atoms. 1 bromine at first carbon, second bromine at second carbon. The name of this compound is 1,2 dibromo. Double bond means ethane, 1,2 dibromoethane. Further, it is reacted with another 2 bromine atoms in the presence of CCl4. Again, the double bond should be breaked and it becomes single bond. H, C single bond C, H, bromine, 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 and here another bromine. The name of this compound is, we have 4 bromine atoms. 1,1, 2,2 tetrabromo ethane, alkane family. That's why ethane. So if you observe this chemical reaction again, this triple bond becomes double bond. Again this double bond becomes single bond. This is nothing but addition reaction. Third one is addition of hydrogen halides. Hydrogen halides is nothing but either HCl or HBr or HA, hydrogen iodide. So we will take HBr. Acetylene is treated with hydrogen bromide. First it forms bromoethane and finally it gives 1,1 dibromoethane. The chemical reaction is acetylene, HC triple bond CH. We are treating with hydrogen halide, that is HBr. So it becomes triple bond becomes double bond like above reactions. C is double bond C, hydrogen, hydrogen. So we are adding HBr, H and Br, one hydrogen at first carbon and bromine at second carbon, HBr. The name of this compound is bromoethane. Further, it is treated with HBr. Again, it splits into H and Br. One hydrogen to first carbon and other bromine atom to second carbon. So, see, here double bond becomes single bond. C, single bond C, first hydrogen, second hydrogen, and third hydrogen in HBr. Hydrogen, hydrogen, and bromine. And this bromine on top of the carbon, HBr. The name of this compound is 1,1 dibromoethane. Dibromoethane. So if you observe this chemical reaction again, triple bond is breaked and forms double bond. Again double bond is break down into single bond. This HBr, H and Br atoms are shared by 2 carbon atoms. Here also H and B are shared by 2 carbon atoms. So and finally it forms 1,1 dibromoethane. Fourth property is addition of water. Acetylene on addition with water in the presence of mercuric sulfate and dilute H2SO4 at 333 Kelvin temperature, it forms first vinyl alcohol. Further it rearranges and forms acetaldehyde. The chemical equation is CH triple bond CH. We are adding water, H2O. So H2O can be divided into H and OH. That means H bond OH. So this reaction takes place in the presence of mercuric sulfate HgSO4 and dilute H2SO4 in the presence at the temperature 333 Kelvin. So one hydrogen is taken by the first carbon. This OH is taken by the second carbon. C H first hydrogen, triple bond becomes double bond CH and this OH. Further it rearrangement takes place. Rearrangement అనేది జరిగి ఇదే ఫామ్ చేస్తుంటే ఎస్టాల్డిహైడ్ ఫామ్ చేస్తుంది. So in this rearrangement one hydrogen is attracted by the first carbon atoms. It becomes CH3, carbon with 3 hydrogen atoms and remaining carbon and this OH, that is we can write it as CHO. The name of this compound is acetaldehyde. By the rearrangement of this compound, this one is nothing but vinyl alcohol. Vinyl alcohol అనేది rearrangement జరిగి acetaldehyde కింద కన్వర్ట్ అవుతుంది. Fifth one, addition of hydrogen cyanide. Hydrogen cyanide is nothing but HCl. Acetylene on addition with hydrogen cyanide gives vinyl cyanide in the presence of Ce2CN2. Copper cyanide సమక్షంలో హైడ్రోజన్ సైనైడ్ అనేది ఎసిటిలిన్తో రియాక్ట్ అయ్యి వినైల్ సైనైడ్ అనేది ఫామ్ అవడం జరుగుతుంది. ద కెమికల్ రియాక్షన్ ఈజ్ ఎసిటిలిన్ C triple bond CH and here H plus HCN, hydrogen cyanide HCN. It can be divided into H and Cn. So this reaction takes place in the presence of copper cyanide Ce2CN2. So one hydrogen taken by the first carbon, second cyanide is one cyanide atom is taken by a second carbon. So again the double bond becomes triple bond becomes double bond. C double bond C hydrogen and the hydrogen and here our hydrogen and it forms Cn. This is nothing but vinyl cyanide. Right, here hydrogen, this is our added hydrogen, this is our added cyanide. This is the addition of hydrogen cyanides. Sixth property is cyclic polymerization. Acetylene on passing through red hot iron tube at 873 Kelvin undergoes cyclic polymerization. That means 3 molecules of acetylene polymerize to form benzene. 3 molecules of acetylene, 3 CH triple bond CH. It is passing through red hot iron tube at 873 Kelvin temperature. It forms benzene. Cyclic polymerization is nothing but 3 molecules combine each other in this way. CH triple bond CH triple bond CH. They can polymerize, that means double bond becomes single bond in this case. Again this triple bond becomes here single bond, this triple bond becomes here single bond. This is nothing but cyclic polymerization. Cyclic polymerization of this acetylene forms benzene. This is the sixth property of acetylene.